35 years of experience in both public and private sectors, including roles at NTPC, UPCL, Enzen Global UK, and Capgemini. An engineer from BITS Pilani, he has led national and international projects in power generation and distribution, specializing in smart grids, renewable integration, and energy efficiency. And today, Mr. Jayant Sinha will talk on technological advancements. So let's welcome Mr. Jayant Sinha.
So I'll be talking about the India energy security and the technological advancements that are being built around creating that long-term energy security, as well as aligning with the roadmap of energy transition in which India has planned to achieve net zero by 2070. So the times are challenging, but we are progressing according to the well laid out plans which have been created by Niti Aayog and also in collaboration with CA, Ministry of Power and Ministry of New and Renewable Energies. So this is the current power scenario. As you can see that our installed capacity as on date is 425 gigawatts, out of which these are the mix of thermal, renewable energy and nuclear. There are, of course, there are few others as well, which includes CHP, combined heat and power, and biomass energy as well. And total energy consumption as of now is 7050 terawatt hours, which is a 8.87 growth from 2022-23. And the power demand is estimated to be over 700 gigawatt by 2047. So all those developments in renewable energy and in low carbon systems are all aligned to achieve this target. So this is an energy mix actually, which I have created. However, I have taken the data from Ministry of Power. It is available, where it's the region-wise distribution of the different energy sources, which you can see the fossil fuel sources as well, coal, lignite, gas, and also the clean energy sources, which includes nuclear, hydro, and renewable energies like solar, wind, and also the low carbon energies like biomass. So these are all, this is the composition here. And the total installed capacity, as I've already mentioned as of now, is 425 megawatt in India. And the renewables on the right-hand side of the column it also includes biomass and cogeneration. Cogeneration is where we are actually using fossil fuels or low carbon fossil fuels, but we are actually converting that, recovering the waste heat into a waste heat recovery boiler so that they can be used to run the steam turbines, and so that we can have maximum energy efficiency as well. There are many security challenges. One, definitely, I think it will be covered also by Mr. Gaurav Upadhyay about the green energy investments, because this is something which is always challenging, because the business case have to be built in order to attract the investors into this area. And another thing is about what are the right clean energy technologies, because when we are talking about energy transition, we have to ensure that our clean energy technologies is the right fit for the kind of projects that we are undertaking. We also have to ensure the standards, the standards which go about, so that we do not have to suffer technology obsolescence, and the technology should be scalable as well. In technology adoption, there are many ways which we have to do it. It's a multi-pronged approach. One is we have to formulate the digital strategies, and within the organization, we have to foster a culture of innovation, learning, and indigenization. Secondly, it is important that the organization itself has the technology maturity level to undertake all these challenges of transition. Then we have a skill development, training, technology financing, and these are all the challenges which we have to remove. And we also knowledge management and collaboration with stakeholders, and enforcing interoperable industry standards, which I have talked about. best practices, which is think global and act local. That is very important. So this is how we remove it. Some of the new initiatives which is being undertaken by different discoms with under different measures. One is active network management. It is about real-time managing your grid about network. It's one of the smart grid technologies, which is an example of IT/OT integration. We manage the grid constraints, we manage the capacities, we also ensure that the demand and supply are met. We also manage the resources. We also manage the aftermath of grid connections when renewable energies are connecting. So all these things can be done with the help of active network management, which definitely integrates with a lot of other OT applications as well as IT applications also, so that the network can be maintained, it can be kept reliable, and the grid is stable at all times, which will enhance ultimately the energy security. Virtual power plant is a new concept which essentially deals with how you manage the different distributed energy resources in real time. So it involves a lot of IoT-based integration, a lot of sensors and communications, and you have to assess the readiness of the different distributed energy resources in real time, and also create a kind of a merit order rating. So which are the renewable energy which have to connect in which sequence, so that the demand versus supply gap can be minimized and the grid is also stable. So it includes a lot of data, which includes like demand aggregation, load forecasting, system availability, pricing signals, and also we have to ensure that we are meeting the compliance standards. The green hydrogen initiatives in India is aiming to achieve 5 billion metric tons of production capacity by 2030. It is also aims to become a global green hydrogen hub, which includes exports and which will contribute to our energy independence. And most importantly, green hydrogen can be used in many ways, as you can see in the diagram. It can be used for green ammonia for fertilizers, chemicals, and it can also be included in power generation, like blending with natural gas to reduce the carbon footprint during power generation, and also for transport using either fuel cell technology or using hydrogen as an internal combustion engine, which is the technology which is being still experimented. But there are a lot of scope of green hydrogen and its derivatives to ensure sustainability in the long run. Then the national e-mobility is all about EVs, creating that EV infrastructure, creating the battery technology to power the EVs, so that we can reduce the emissions. And the target is to achieve 30% of electric vehicle penetration for private cars, 70% for commercial vehicles, 40% for buses, and 80% for 2 and 3 wheelers. So for this, we also need 2.9 million public charging points, which will be for an estimated 102 million EVs that we are estimating by 2030. So certainly e-mobility transformation is a plan which intends to provide India a great leap towards emission reduction. And but of course, this will, though this has challenges, but it also has the potential to create jobs. It also has potential to create local domestic manufacturing of batteries, and this definitely will be contributing to sustainability as well. So grid management, I have discussed earlier in my one of the slides, but then I would like to also emphasize on the power quality management issues, which are being actually grid is being constrained because of the variable renewable energy which is being connected, and we very well know that they are subject to the weather uncertainty and also the demand fluctuations. So all these things will create grid instability and power quality management problems. And there are a lot of technologies like sensors and all those things, IoT, which can be used to monitor in real time, and this is being used as per the CA guidelines. Then this is the last slide where I will be just, these are not the only one, but these are the technology trends and practices which are being used, like virtual reality for digital simulation of the utility networks in order to ensure, so that, you can actually create a digital simulation with a lot of real-time data so that real-time decisions can be taken, and monitoring becomes faster so that you can proactively act upon any fault, and diagnosis also becomes simpler. So similarly, Internet of Things, it's all about sensors, because now we are playing with a lot of data. When renewable energies are connecting with the grid, we have to monitor in real time the grid parameters. We also have to monitor the asset conditions, so that and for this we need to have a robust communication system and cybersecurity as well, which I have mentioned. Drones have been used for inspection in few cases, though this is very experimental in India. But Power Grid has used drones for hotspot inspection, monitoring of the transmission line sags, and also the structures, and also corona discharge, deformity, and also for the planning also when they have to lay new transmission lines. Blockchain, of course, you must have heard of, because this is an added layer of security when a lot of prosumers are coming into the market, and they have their own rooftop solar and different distributed generations by small commercial and industries like wind power as well. So they want to trade their surplus energy, and blockchain platform offers safe and transparent platform to transact energy. And of course, the last but not the least is cybersecurity, because we are dealing with the critical infrastructure, and we have to ensure that all our IT and OT infrastructure, as well as the critical national infrastructure, is protected, and ensure that there is no sabotage which could lead to breakdown of the services. So cybersecurity solutions are being